presentation that I haven't done before. It's like pieces out of existing presentations. So I'm in the Department of Art and Design here at Towson, created and founded the Object Lab and the Object Design Program. I work collaboratively with industry, educational institutions, advocacy organizations, and the community. Hopefully, our goal is to advance rapid tech in the Baltimore region. I do this through a number of roles, the ones that you already know about, but also leadership roles in conferences like Next Gen M, Rapid Tech for Make and Manufacture, and a Rapid Tech Leaders and Learners group, which we are in the midst of launching right now. And then also engagement with and integration of external partnerships in the curriculum in the lab. I'm passionate about emerging technologies, design, innovation, entrepreneurship, real-world education, and how rapid technologies can advance industries and society. So the Object Lab, you're looking at it here, and I kind of want to dim the lights. You kind of can't see that very well. Will you guys fall asleep? You have had pizza, and I'm the fourth speaker. This is a test. Don't fail. So this is the Object Lab over in the Center for the Arts. It's a comprehensive, state-of-the-art rapid technologies and digital fabrication lab. We encompass 3D laser scanning and imaging, 3D computer modeling, 4 different types of 3D printing or additive manufacturing, CNC milling, and laser cutting. Okay, next. So some of what we have, was one of the requests. So we have 4 different types of 3D printing technologies. There are many more out there. We just started at this particular junction. So Z-Core is one of the 3D printing machines that we have. It prints in a plaster, I'll say it that way, the easiest, prints in a plaster. The Objet is a polypropylene-like material, which is very sturdy. SolidScape is a wax printer and is the finest print that we have. Some of our prints run for 72 hours, but they can go from the build table into industrial processes. We have a CNC mill and then also a laser cutter. And then the other images here are just some different clients that we've worked with. All right, so I'm really excited about this. Rapid technologies are revolutionary. They're changing how we make things across industries, and that's one of the things that I just find super enthralling. It's also changing who, what, where, when, and how we make and consume. So this is hitting the consumers, which some of you may know, but also all the products around us. It affects the body itself, housing the body, and protecting the body and defending the body. In other words, biomedical, consumer goods and consumer markets, construction, and aerospace and defense, all from one suite of technologies. I'm going to focus just for a minute on 3D printing, also called additive manufacturing, because it's a revolutionary technology, and I want to give you 4 ways that it's revolutionary. It can produce complex geometries, and what this means, where we had to previously we've had to design around existing processes and technologies. So the parts that we made were dependent on what we could make. Now we can make anything. So now where we might have 5 parts, we have 1 part. So additive manufacturing increases efficiencies in multiple directions. There's a lot less waste in manufacturing, and there's a lot of materials. Some of those materials are lighter weight, resulting in even more efficiencies. The time is right for entrepreneurs to reinvent industries, and some companies coming online today are choosing to digitally manufacture their products. The second revolutionary point is complexity is free. These machines can run, or they cost the same to run, whether the part is simple or complex. Locality, globality. Digital files can be transmitted anywhere in the world, localizing production. And this is hard for me to kind of gloss over throw these statements out. I'm happy to give you real-world examples because there's some really compelling and exciting ones out there. And then the fourth revolutionary point is that it's mass customization, which most of you are familiar with. So these are game changers, and these aren't the only factors. I haven't even talked about online platforms and how these things hook up with each other. So rapid technologies are disruptive, creating potential for positive economic impact, but also helping us compete in a very fast world. Every facet of the physical world is going to be changed by rapid technologies. Where there's innovation, there are opportunities. Where there's opportunities, there are entrepreneurs. And I want you to think of the Object Lab, those of you who are thinking are entrepreneurs in physical form. Next slide. So some of the technologies. So I present on just the technologies, I present on just the lab, I present on, another thing I'm going to talk about is design thinking. I present just on that. So I present on these things pretty much in depth. I chose still images tonight because the videos just they eat up the time, but it's really hard to get this from just still images. So 3D printing, what do we mean? It's very similar to how an inkjet printer works. Instead of depositing ink onto a page, it's depositing a material layer by layer, building up an object. And that definition works across all the technologies. All the technologies and materials are different in almost every case, but that is a pretty good working definition. There are many materials that are used with 3D printing, from titanium, steel alloys, many other metals, to a wide range of plastics, ceramic, glass, concrete. The material characteristics of the printed materials are very comparable, becoming more and more comparable to traditional materials. Additive manufacturing is used to produce concept models, functional prototypes, end-use products, and tooling. Connecting to Reese's concepts of minimum viable product and the build, measure, learn loop, 3D printing is inherently lean. It uses only the material required by the design. If you compare it with traditional CNC milling, there's a ton of waste. And prototyping is inherent to 3D printing. The technologies and materials are evolving continuously, and it will. It's definitely a game that you have to stay on top of constantly. So laser cutting is exactly what it says, and this is you get the example of laser cutting there. So using lasers to cut through materials precisely, quickly, and in an automated fashion. The job parameters depend on the strength of the laser and the cut table. CNC milling, probably more familiar to most of you, as we know it in a traditional form. Now we use a computer to drive the designs to the mill and then cut the material that way. So again, automated and precise. And then the other one that is the hardest to talk about, and my colleagues who do 3D scanning and imaging, my heart always goes out to them, because I don't know how they sell. They have to have spend a lot of time and energy selling. 3D scanning is using lasers to measure existing objects. So a laser will pass over an existing object, pick up the data points that describe a volume or describe an existing product. And then the imaging part comes from what I call solidifying, or putting that data into a usable form that you can then manipulate and then send to an output product or an output process. And that is mainly used in reverse engineering. Okay? So rapid prototyping. It's a primary use of additive manufacturing today, although rapid manufacturing is there. It's on the heels primarily in aerospace and biomedical. Benefits of rapid prototyping include getting to market faster, getting to market cheaper, market testing prior to commercialization, proof of concept, iterative prototyping, small batch manufacturing, just-in-time manufacturing, printing on demand, and printing anywhere there's a machine. And that's really one of the key points. Creating complex geometries, we talked about that. Optimizing the production processes, rapid product development. Under Armour has some really great examples of this. And then again, the mass customization. In a competitive and uncertain world, rapid technologies help us to compete. And I think all of us are feeling that pressure right now. And we look at the world stage and what America's role is, what America's role in that is. We've always delivered invention, imagination, design, innovation. And I think it's time that we reinvest and up the ante in that way. Search. All right, so Sarge said, what do you mean by design thinking? Okay, left turn. Design thinking is another one of those things that I just find really compelling. Design is problem solving. I'm trained as a creative. We imagine something or get some idea in our head and we can figure out how to make it. We think that's how we think, and if there's engineers in the room, you're probably thinking we do too, or maybe all of you think that because you're all innovative and entrepreneurs. Whether it's a new algorithm, a coffee pot, or a theater production, it's all the same process. The products are an expression of the thing imagined, useful or aesthetic. So I'm passionate about the design part because embedded in the thing that we create is an ethos. And the ethos reflects back to society or the maker what it values. And I think that's a terribly exciting idea. So this means we can create all of our world from systems and politics and education exactly how we want it to be. So I always say to my students and the people I work with, what are we creating here? And it's time that we get a little bit more competitive than we've been. So designers think differently, and this is why in the last 10 years or so, people are looking at designers and the design process and design thinking. How do they do what they do? So like so many people before him, Reese adopts a lot of the essential parts of the design process: plan, sketch, iterate, etc. Let's see. Fail early, fail often. Designers and artists are used to doing that all the time. You make something, as soon as the first iteration's out, that doesn't work. You make another one, you make another one, make another one, before people even see it to have feedback, to give you feedback on it. Okay, so what is design thinking? It's a question that I get. There's many different definitions. The first one I'll put out, re-abstracting the problem, is probably my favorite, because what's possible shifts drastically. The constraints change, permitting a business to choose from a wider range of initiatives. The new frame is wider, more open, and allowing current technologies to be engaged. And here's an example. An apparel company who embroiders logos on clothing, say for groups like Girl Scouts or Nike, re-abstracts the problem of who they are in 2012. And they become an identity company rather than an apparel company that embroiders logos on clothing. The parameters have just shifted, and their business initiatives that they can pursue are wide open. Another definition is the traditional design process adopted by the business world, balanced with analytical tools that arrive at innovative solutions. The first definition is my favorite, but I love the second one too. And everyone's using this, from Shimano to the Mayo Clinic to the UK Design Council, trying to solve social problems in the UK. So who uses design thinking? Everyone. So here's just some names of people and institutions and disciplines that are engaging design thinking. And like I said, I talk about this. You can Google me. Some of my presentations are online. I don't know that my Prezi presentations are public, but talk to me. I'm easy to get along with. Okay, last slide. Okay. So Sarge wanted to know about, what about the professional community in the lab? And I say, my answer is always yes. Come to me, we'll figure out how to a way to make it work. I subscribe to the collaborate to compete philosophy. I believe we, America and Maryland, need to work together in order to be competitive in this nation and in this world. And there's evidence that this is a growing ethos in America. And you can look at Obama's recent NNMI initiatives, the National Network of Manufacturing Institutes, and the parameters around those, what parameters you have to fit in order to qualify, are a very good indication. I think competitive competition is a good thing. I think it's a healthy motivator, but we need to pool our resources and engage new ways of working in order to prosper. Disruptive technologies have shown us what we already know. We need to work together to solve problems, and collaborative technologies have led us to solve some of the biggest problems. Look at Foldit, look at Innocentive. And more entities are responding to collaborative working models to address big issues. So as an educator, I say, why should I not be engaging the very models that are on the leading edge? And I think the answer is you should, and I'm trying, or I'm doing it. Rapid technology itself needs to be accessible, period. K through 12, university students, the entrepreneurial community, C-level decision makers, people running it, do they know about the technology that they're going to have to engage, or the company's going to have to engage? Inventors, experimenters, tinkers, everyone. We need everyone on the playing field, and that's how we're going to all win. We need to foster cross-pollination. We know this, and the Object Lab is doing it. We all have to innovate to compete. Everyone's in the same game. So GE's doing the same thing that I'm talking about. Everyone's in the same thing, figuring it out. We're in unprecedented times. How can we all be doing the same thing? I think it's exciting. What I'm most interested in are the intersections and finding ways of working together. I'm now known for the statement of, like, go to Jan. She says yes. She'll figure out how to do it. But I think that that's a good model. So the Object Lab's competitive advantage is that we're a comprehensive lab. People can come to one place and learn the entire life cycle of rapid technologies, from collecting the data from the imaging to the 2D to the 3D, and then various forms of that. And then learning the advantages of one technology over another. So I think Maryland's uniquely poised to be a center of advanced technologies, and that's something that I'm involved in and advocating for, and putting networks together. So if you missed our Next Gen M Rapid Technologies for Make and Manufacture conference, or if you want to be in the Rapid Tech Leaders and Learners Network, make sure you get to me. I'll put you in. We are planning a conference again for next year. It happened in April of this past year. Thank you for your time, and I'm happy to answer any questions.